We just said on this one, okay, SiBr4 is in the middle. All right. I'm sorry, Si is in the middle for SiBr4 rather. So Si is in the middle, the Brs are going to be on the outside. How many does Si get? Yeah, it is 4. It's in the same row of carbon there. Okay, each Br gets 7, so that's a total of 28. My grand total is going to be 32 then. So give each of my Brs 7 here. And if my dots look stupid, I apologize. The stylus is not fun to write with. Okay, so I'm going to connect 2 dots, 1 from each here, to the center atom. All right, at that point, again, I got to go through with my count. I got to make sure that I have enough around each one. And in this case, they all still need 8. And when we go on to further examples after this, there's going to be a few that don't, that I'm going to show you. So I'm going to count my BRs first. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Okay, so everything has 8 that needs 8, so I'm good there. Next thing I need to do is I need to count all of them, and I need to make sure I have 32. So I'm going to start up here at the top. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. So I'm good. Once I make sure everything, like I said, once everything has what it needs and then the total number's correct, you're good to go. All right, so there's what our structure looks like once I remove those. Okay, hopefully we got that right. We do good on it? Okay, so let's go on from here. CH3Cl. Now I'm going to do this quickly for you. I just want to prove a point here. This is one that is similar to one that's on the work we're going to do with this, and people are getting confused. But if you think about it, CH3Cl isn't much different than CH4 or CCl4 or CBr4, whatever. It's just 4 things attached. Does not matter which side we put that Cl on. Okay, so if I draw this out, I put the Cl here, the 3 H's here, and the carbon in the middle. Okay, when I actually do the work, we're going to come out with a molecule that looks like this. Okay, that's don't let it confuse you if you see stuff that's mixed up. It's still just 4 things that were attached. Okay, moving on from there, AlF3. Okay, now, here's where it gets a little tricky. Al is in group 13. I told you group 13 only has 3 valence electrons, so they can only make 3 bonds. So what that means is that my center atom is not going to have 8 valence electrons in this case. All right, so Al's in the middle with the 3 F's on the outside. All right, Al gets how many? 3 valence electrons. 1, 2, 3. Each F gets 7, so that's 21, total of 24. Okay, so 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Connect, connect, connect. Now, if Al can only make 3 bonds, how many electrons should it have surrounding it then? 6, yeah, you're right, 6. Okay, in this case, let's count to make sure everything else has 8 and that our Al has 6 then. 2, 4, 6 on the Al, that's right, 3 bonds. 2, 4, 6, 8 on the F. 2, 4, 6, 8 on the F. 2, 4, 6, 8 on the F. Okay, so that's good. Then I got to go back again and count my totals here. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, which was my target number, so that's good. Okay, so that's correct. Now, I want to give you the explanation of this real fast, though, at least so you know what it is and what it's called. When the center atom, okay, has less than 8 valence electrons, this is what's called an incomplete octet. Okay, that's the name for it. And this happens when you have a compound that's ionic, usually it has a group 1 metal, a group 2 metal, or a group 13 metal in it. Okay, because they only have 1, 2, and 3 valence electrons, meaning they can only have 1, 2, or 3 bonds. What'd you say?
I have a question.
Go ahead.
So like, what if like someone put it in a different order and put the iPhone on top? Would you take points?
No. Yeah, it does not matter where you draw those. I draw it for simplicity's sake like that. When we get to the shapes, you'll see how that actually sets up the right way. Okay, two more examples I want to go through real quick here with the last couple minutes of class. MGBR2. I would expect Mg to have an incomplete octet. And I know that because it's in group 2. You know, it can only make 2 bonds. All right? So, if it can only make 2 bonds, that tells me right away it has 2 valence electrons. Okay? Each Br has how many? 7. So that's 14. That's 16 total. Bond, bond. Okay? Mg is only going to get the 2 bonds because it only has 2 valence electrons. So, when I count, Br has 2, 4, 6, 8. 2, 4, 6, 8. Mg has the 4 it needs. When I do my final count, 2, 4, 6, 8, 10, 12, 14, 16. So again, this is an incomplete octet on the center atom. It means it has less than 8. Okay, you need to know what that means. Okay, real quick, one more example here. If you see something like this that has a 5 or a 6 in it, okay, that is kind of a telltale sign right away that you're going to have what's called an expanded octet, which means you're going to have more than 8 on the center atom. Now, these are real easy to recognize and real easy to know what shape they take when we get to the VSEPR structures, okay, because there's only one thing they really do. P has how many? 5. 1, 2, 3, 4, 5. Well, and I see there's 5 Cls attached, so that makes it real easy. That tells me right away that one of these each is going to be attached to a Cl. So it's going to look kind of like this. Okay, and yeah, I can draw the dots in. The right structure would have all the dots, blah, blah, blah. Okay, so that's what it looks like. Now, what I said was, if you have more than 8 valence electrons, this is called the expanded octet. Pardon my handwriting again with the stylus. Does not look nice. All right. And again, you'll know when that happens because you'll see a 5 or a 6 in there. There are like way bigger exceptions to this kind of stuff, but for the basic stuff of what we're doing for the 8 shapes we're going to look at when we start talking about VSEPR, this is the main thing. Okay, any questions on this?